Morning. Today, we are going to have a chapter review on correlation and regression analysis. These are the lesson objectives that we have learned for the past three lessons. We have described the nature of bivariate data, construct a scatter plot, draw the best fit line, estimate the strength of the variables of the relationship, calculate the Pearson R and interpret its results, and apply and solve real-life problems involving correlation analysis. We have also identified independent and dependent variables, calculated for the slope and y-intercept, and interpreted and have predicted the value of the dependent variable. Let's start with our chapter review. Correlation analysis is a statistical method used to determine whether a relationship between two variables exists. For example, if we want to check whether there is a relationship between height and a person's arm span, then that method is called correlation analysis. We have talked about scatter plot. Scatter plot is the best diagram or graph that is used to represent the relationship of two variables. It is like plotting points in a Cartesian plane. It's also called scatter graph or scatter diagram. And to check or to estimate its relationship, we are drawing a trend line. Now, how do we describe relationships? We can describe relationships based on strength. We say how close are the points to the trend line, and we can also describe relationships through the direction. Is it positive, negative, or no correlation? Let's first have the direction of correlation. The direction can be positive if the slope is positive and our trend line rises to the right. It's also negative correlation if its slope is negative, or we say if one variable increases, the other variable decreases. Its graph is going down, or we say it rises to the left. And if there are no indicators whether it goes to the right or goes to the left, we say that the direction is of zero correlation. The trend line is what we're going to draw to check the strength of the relationship of the variables. The trend line, or the line of best fit, is the line closest to the points. It tells us the direction of the line and also the direction of the correlation. If the trend line rises to the right, then it's of a positive correlation. If it rises to the left, it has a negative correlation. A trend line whose points are all in the line, we say there is a perfect correlation. Now, how do we solve for the correlation coefficient? We have been introduced to the Pearson product moment correlation coefficient, or we commonly call it the Pearson R. Here's the formula, and it is used to indicate the strength of the correlation. If the R is positive, then there's a positive correlation. If the R is negative, then there is a negative correlation. How do we do it? For example, this is the given data. So we need to fill in the x squared, the y squared, and the xy column, and then also have its summation. Or you could refer to the technology tutorial 2 on how to do it using Microsoft Excel. Then we substitute these values in the given formula, and we have our computed R is 0.90. You can pause this video and try this one using Microsoft Excel. Now we interpret it. Here is the given interpretation. And based on the computed, that's 0.90, that's positive. So we say it's positive, and the relationship, or the strength of the relationship is very high. Now, how to test the significance of R? First is, here's the formula for a test statistic T. That's R for correlation, and N is the sample size. Remember that the degree of freedom is N minus 2, no longer N minus 1. In this testing of significance, we need to use our T-table, two-tailed. Here are the steps used to test the significance of R. First is We just state the null and the alternative hypothesis. Then step 2 is to compute for the t. Step 3, we compare our computed t to our critical value. And step 4, we need to write our decision and conclusion. Now, we go back here. If in our decision there is a significant relationship, then we proceed to regression analysis. However, if there is no significant relationship, we could not proceed to regression analysis, and it ends there. So how to solve for the regression analysis? First, to identify the dependent and independent variables. If we say dependent variables, these are the variables being predicted. And the ones that predict dependent variables are called independent variables. To solve for the regression line, or we say the equation of the trend line, we need to have this equation. That's y prime equals bx plus a. B is called the slope of the regression line, and a is the y-intercept. The y prime and the x are constant. Here's the formula for a and b. Where do we get the values? We go back to our completed table. Remember, there are summations. That ends this one for a short chapter review.